buddies, Vaish here. Today we are heading on to chapter number 8, Motion for grade 9 Physics, a new start. So today we'll be seeing what are the topics we're going to cover in this chapter Motion, and today we'll be heading on to two important topics. Let's get started. Okay, Motion. So let's see what are the topics we're going to cover in this chapter Motion. Number 1, types of motion. There are two types of motion, uniform and non-uniform motion. Under uniform motion, we'll be learning about uniform circular motion, and we'll be learning about non-uniform motion. The next one are the two important ones, distance and displacement. We'll be covering about distance and displacement in this video. Okay, so these are the two topics we're going to cover in this video. The next one is rate of change of velocity. So rate of change of velocity is acceleration. We are going to learn about speed, velocity, average velocity and acceleration. So the next important and interesting chapter we're going to learn is graphical representation of motion. Graphical representation of motion is very interesting and important one. We'll be learning the equations of motion related to graphical representation of motion. Let's get started with today's topic. So first we learn what is motion. Change in position of an object in relation with a reference point is known as motion. Now, reference point. Let's see what is reference point now. Reference point. Any point on a location about which the motion is determined. Reference point is known as origin also. Any point on a location about which the motion is determined. It is a point. Okay. So let's come back to our slide here. Okay. See. So now let's mark the reference points here. So I'm going to mark like this. Here. So these are the reference points. We have case 1, car number 1, car number 2. So motion is nothing but change in position. So of an object, change in position of an object. So we have case 1, car 1 and car 2. So when we just see the car 2 has moved through a distance and changed its reference point. So you can see here there is a distance between the reference point and now. But whereas in car number 1, it is in the same position. So the object is at rest. Object is at rest. So sorry for this bad handwriting. Okay, the object is at rest. So it is in the origin. It is not changed position. So the object is at rest. But in case 2, it has moved from its reference point through a distance. So the object has taken up motion. Okay. Change in position of an object in relation with reference point is known as motion. So the reference point, we learned it. Now, distance. Distance and displacement are important topics. Make sure that you are thorough in it. Okay. Now, distance. Total path covered by an object is known as distance. So, total path means here total path or length. So, for example, this is your house and this is your school. So, your distance from your house to school is about 10 kilometers. So, what is the distance covered by you? 10 kilometers. Okay. So, now case 2, think of it. You're traveling from your house to your school and returning back from your school to house. So what is the distance? See that distance is the total path covered by an object. Distance is the total path covered by an object. You're traveling from your house to your school and returning back to your house. So what is the distance covered? 20 kilometers. How? From your house to your school it is 10 kilometers. Again, returning back from your school to your house is 10 kilometers. So 10 plus 10 is 100 kilometers. Sorry, 20 kilometers. Okay. So the distance covered by you is 20 kilometers. Distance is nothing but total path covered by an object. Okay. Yes. So talking about displacement. Displacement is nothing but the shortest distance measured from the initial position and final position is known as displacement. So same thing. You have your house and your school over here. You're taking a path which is about 15 kilometers length. So you're taking like a path that is 15 kilometers in measure, and you also have a small path like a straight line that is 10 kilometers. Usually, displacement is a straight line. So now listen. The shortest distance measured from its initial and final position. Let's mark my house as U and the school as V. So initial and final position. Okay. Initial position is my house and final position. Distance is what? Total distance. Total length or path covered by an object is known as distance. So shortest distance is known as displacement. So here 15 kilometers you have and path which is lesser than 15 kilometers. Yes, 10 kilometers. So here the displacement is 10 kilometers. So from initial to final position, we have a path of 15 kilometers, also 10 kilometers. So the displacement is 10 kilometers. So in such some cases, the displacement can be zero. Displacement can be zero. Let's see how. Now, make sure that initial and final position. The same thing, your house is U, in your school as V. You're taking a path of 10 kilometers. Just leave this 15 kilometers now. You're taking a path of 10 kilometers. So you're traveling from your house to school about 10 kilometers and returning back from your school to your house, that is 10 kilometers. So what is displacement? The shortest distance measured from initial and final position. What is the initial position here? House. Your house to school is 10 kilometers. So here displacement is also 10 kilometers. Now see that you're from your house, from your school to your house, you're returning back. So the initial position here, it is not the V here. It is not the final position. You're first moving from here to here, then returning back from there to here. So you can see the initial point, the house is your initial and final position. So the displacement is 0. When your initial and final position is the same, then displacement is 0. But your distance is not 0. Let's see an example here. Here the boy is moving in a straight line. You can see he's moving. Now he's going in a curve. That is, he's starting from here, moving like this, somewhat like here's going, reaching the point. See? Yeah. See, all face has that displacement is a straight line. So you can see that the length. See, I am using a string rope to measure the length. So when we measure the string rope from a house to my, okay, let's have my friend's house to my apartments is the measure of your string is about 150 meters. Okay, straight line. So this is measuring about 150 meters, but the curved line is measuring about 250 meters. So always see that the straight line has the measure less other than the curvy lines. So mostly the straight line is of displacement. See, going with this to that. Okay. So let's head on and see the distance and displacement prominent differences. So every time when they ask you write the difference of displacement, distance or anything vector or scalar, the main thing you're going to write is its definition. So distance is total path covered by an object, whereas displacement is shortest path covered by an object. Distance is a scalar quantity, displacement is a vector quantity. Distance are measured in positive and zero. Displacement can be negative, positive or zero. So if you move forward, the measure will be taken as positive. Okay. When you move backward, the measure is taken as negative. Okay. See here. When your distance is taken only in positive. Why? Distance, the total path. See your I'll write it here. There is a straight line. Okay. So here is that line. From here, this is the starting point. You're moving about 5 kilometers here. So 5 kilometers. Again from the 5th kilometer, you're moving back to 10 kilometers. Okay, so no, this measure is 10 kilometers. So what is your distance? 10 plus 5, 15 kilometers. But whereas displacement is 10 meters positive, 10 kilometers positive. Another back 10. So it is in the negative. Okay, considering distance, it is only positive or zero. Zero in both cases, distance and displacement. When the object is at rest, it is zero. But in distance, always when the object is in motion, it is only in positive. Whereas displacement, it can be in positive, in negative also. Okay, so these are the three important points. Let me talk about other things. So always the distance is greater than the displacement. So distance is equal to displacement, or distance is greater than displacement. Displacement is lesser than distance. Okay, these are the two things you can write. Okay, so and distance is not lesser than displacement. Displacement is not greater than. So these are three things you can add it on extra. Okay, so these are the prominent examples. Now we'll head on to the prominent differences. Now we'll head on to the in-text questions, the three questions given in your textbook. So question number 1, an object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. The same thing. First define what is displacement. Displacement is nothing but the shortest distance measured by an covered or measured by an object from its initial to its final position is known as displacement. So, can it have zero displacement? I have explained. So, when the initial position and the final position of an object is same, the displacement is zero. Support your answer with an example. Just draw this diagram if needed. Otherwise, just write it in a statement. Okay. Second question, a farmer moves along the boundary of a square field, say 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes and 20 seconds? At the end of 2 minutes and 20 seconds. Now see here, the side of a square field is 10 meter. So the farmer can cover the whole boundary of the square field in 40 seconds. What is boundary? Perimeter. So now we'll calculate what is the perimeter. 4a of a square. So 4 times a is 10. 4 into 10 is 40. So the farmer can cover 40 meter in 40 seconds. So in 1 second he can cover 1 meter. Is it right? In 1 meter he can cover in 1 second. In 1 second he can cover 1 meter, vice versa. So what will be the magnitude of displacement? Mention the word displacement at the end of 2 minutes and 20 seconds from its initial position. So 2 minutes and 20 seconds convert into seconds. 2 minutes is nothing but 120 seconds. How? 60 seconds into 2. 120 seconds. 2 minutes and 20 seconds is nothing but 120 plus 20 seconds, which is equal to 140 seconds. Now, let's go with steps here. A is equal to 10 meter. Perimeter of the square is equal to 4a, which is equal to 40 meter. Time taken by the farmer to cover one round is equal to 40 seconds. Here round is nothing but perimeter of the square. So 40 meter he can cover in 40 seconds. So in 1 second he can cover 1 meter. 1 meter he can cover in 1 second. Vice versa. Okay. So in 2 minutes and 20 seconds is nothing but 140 seconds. So in 140 seconds he can cover 140 meters. One round, that is one round of the perimeter of the square field is 40 meters length. Now in 140 meters is equal to how many rounds? 140 by 40. So 0 0 will get cancelled. 4 3 times 12 and balance 2.0 will come down to 3.5. So 3.5 rounds will be your answer. So now we have got that. Now they are asking magnitude of displacement. So now for the magnitude, so these sums you should of course add upon with the diagram. Now for finding the magnitude of displacement, let us introduce the values. So let's mention A, B, C, and D in the diagram. So for example, if the farmer is starting on in the position A, here he is gonna complete 3 rounds, 3.5 rounds. So first we'll take 3 rounds. 3 rounds means he'll come to its same position. So what is the displacement after the farmer? After 3 rounds. 3 rounds means A to B, C, D. 1 round A, B, C, D. 2 rounds A, B, C, D. 3 rounds. So he lands in the same initial position. Initial position is A, final position is A. So what is the displacement? 0. We have 0.5 rounds balanced then. So 0.5 rounds is nothing but A to B, B to C. 5 rounds. So the displacement is 0.5 rounds. Here you have 10 meters. Here you have 10 meters. So the displacement is, magnitude of displacement is 20 meters. Please write this down and support your answer with an example. I hope you have understood. So this is how we're gonna write it. Okay. So up to this, these are the steps. Then these all you can write it in your own words. Now heading on to the last question. What of the following is true for displacement? It cannot be zero. Its magnitude is greater than the distance traveled by the object. Okay, first one, it cannot be zero. How it cannot be zero? Displacement is a vector quantity. It can be positive, negative, or zero. So first one is false. The second one is true. No. Read the question. Its magnitude is greater than the distance traveled by an object. No. How can be displacement be greater than the distance? Distance is the total path covered by an object, whereas displacement is the shortest distance covered by an object. So both are false. Both these statements are false. So I hope you've understood. You have learnt about motion, reference point, distance, displacement. We've seen with examples, and we have seen the differences between distance and displacement and worked out 3 in-text sums. Okay, so I hope you've understood everything clearly. So if you like this video, don't forget to like, share, and subscribe to Shining Stars, and I'll be posting more videos related to this. Stay tuned. Thank you.